Hello, my name is Susan Latanzio from the Trend Research Group at the University of Bath. Today I will be presenting our paper entitled The Transdisciplinary Engineering Index Towards a Disciplinary Maturity Grid. To provide you with some context, manufacturing plays a significant role in the UK economy, contributing 191 billion of economic output and employing 2.7 million people. In the face of plateauing productivity levels and a widening trade deficit in manufacturing goods, together with uncertainty around the UK leaving the European Union, UK government aims to ensure the resilience of the sector. UK research and innovation recognises the potential benefits from adoption of transdisciplinarity within manufacturing, and in 2018 awarded Trend 1.8 million for research focused on enabling transdisciplinary working within the sector. The ultimate ambition of the group is to design and validate a transdisciplinary engineering index. The index will comprise of three elements: a means for industry to assess their current disciplinary state, a means for industry to assess the level of disciplinary working that is required, and tools to help them move from one level to another. The focus of this paper is the first of these three elements, a means for industry to assess their current disciplinary state. This is approached through the creation of a disciplinary maturity grid. Maturity assessments are extensively used within industry, both as an informed approach for continual improvement and as a means for self or third-party assessment. Although the term model is often used as a catch-all, the literature identifies two distinct types of maturity assessments: capability maturity models, CMM-like models, and maturity grids. In the context of a TE index, a grid was preferable to a CMM-like model for two main reasons. First, the CMM-like model is built on the belief that there is a best practice. When it comes to disciplinarity, we assert that there is no best practice. Rather, different disciplinarities will be more or less appropriate depending on context. Second, a matrix is simpler and has a less prescriptive format than a CMM-like model. In this way, it is more suitable for self-assessment and offers more flexibility for combining with the other elements required to form the index. Having decided a grid is most suitable, we ask, what are the main design elements of a grid? Grids are presented as a matrix, each having a number of maturity levels and a number of dimensions, with assessment questions to evaluate the maturity level of each of the dimensions. On the screen, you can see an example maturity grid, the Energy Management Matrix, produced by the UK's Carbon Trust. On this figure, you can see it has 5 maturity levels, 0 to 4, 6 dimensions: energy policy, organising, training, performance measurement, communication and investment, and maturity questions defined for each dimension at each level. Trend recognised the design of a maturity grid to be an iterative process in which a preliminary grid is created, evaluated and then evolved. As such, the 5 steps defined by Mettler were selected as the methodology to be followed in the design of the disciplinary maturity grid. Step 1, identifying need and opportunity, was addressed within the funding request bid documentation that identified a need within UK manufacturing to develop transdisciplinary capability. Step 2, define the scope, e.g. the focus and the audience, was constrained by the terms of the funding award. Step 3, design the grid, or design the model, is undertaken by way of the workshop described in this paper. Evaluation of the design, step 4, and reflect evolution, step 5, will be undertaken as future work. Workshop approach. The workshop comprised of 12 members of the Trend Research Group, all experienced in transdisciplinary concepts and research. In creating the grid, the workshop looked to address 3 questions. How many maturity levels should the grid have? What dimension should be included? How should the maturity assessments questions be defined? Maturity levels. Typically, assessments are seen to have between 3 and 6 maturity levels, with the most common number being 5. With no literature to support the optimum number, a decision was made that the disciplinary maturity grid would contain 5 maturity levels. What dimensions should be included? In designing the grid, ensuring that the relevant dimensions are included will be fundamental to its success. To uncover these dimensions, a research experiment was undertaken. This experiment is presented in detail in the work of Holton et al. 2021, but in summary, it involved clustering of things described as transdisciplinary within the Scopus literature. Within the workshop, we used a Delphi-like approach to arrive at names for these clustered. This method is fully described in the paper. How should the maturity assessments questions be defined? Within the literature, it proposes that when designing maturity assessment questions, the literature provides a starting point. However, for richness, the literature should be considered alongside other inputs. This figure shows the inputs brought together in defining the maturity assessment questions. Again, the method is fully described within the paper. The result of the workshop was a first draft disciplinary maturity grid. It will be difficult for you to see, but you can view it properly in the paper. Points to make. The literature highlights that little attention is given to how the number of levels within a maturity grid is decided. In the absence of a more rigorous approach, it was agreed that the disciplinary maturity grid would have 5 levels, thus reflecting what the literature shows to be the most common number. Despite making this design decision, for 2 of the dimensions maturity assessment questions, 6 levels were defined. This raises the question, can the different levels for these dimensions be adequately encapsulated within 5 levels, or are more levels necessary? Similar to the number of levels within the literature, there was little discussion of how the dimensions were selected. On the rare occasions where this was provided, it was justified as being evidence through the literature, or chosen based on the inputs of experts. Within this work, we used the literature and extracted the types of things which have been given the label of transdisciplinary. Although a rigorous approach to identify the clusters of transdisciplinary things, do these translate to be the important dimensions? Through a collaborative approach and utilising various input sources, the participants were able to define the maturity assessment questions. However, during this process, a specific question arose. Should the assessments questions be phrased as objective or subjective measures? Within the literature, this question is given little consideration. Indeed, within the work of Mettler, which seeks to define the parameters which should be considered when designing a maturity assessment, although the question of application of method, i.e. whether the grid is completed as a self-assessment or with the assistance of a third party or certified professionals, and the respondents, i.e. management, staff, business partners, etc., are both included, the specifics of whether the questions used in the assessment of the maturity are objective or subjective is not. Conclusions and future work. The literature shows that there is a hierarchy of disciplinarities, which starts with single, mono, moves through multi and inter, and ends in transdisciplinarity. We propose that in assessing disciplinarity, it is in effect a measure of maturity. We bring together understanding of the constraints, evidence from prior research studies, and expert knowledge to create a preliminary disciplinary maturity grid. The grid comprises of 5 maturity levels and 7 dimensions, and provides one element towards the ambition of creating a transdisciplinary engineering index. Verification and validation studies will adopt a TD approach in which the perspectives of industry who will use the grid are captured and incorporated.